isomerism question. So structured essay, A-level paper is structured essay question number 4 from organic chemistry, but mostly the organic chemistry they combine organic reactions, reaction mechanism, then isomerism part of all, like not mostly they ask from alkenes, but sometimes they can combine from the other functional group also. So you learn isomerism separately, reactions mechanism separate, but they incorporate all this in question number 4. Compulsory question is structured the same. Even last 2 years they have given the same pattern. I will share the screen and show you. Right, so you can see the screen now. You can see here this 2020 paper, A-level 2020 A-level paper. You can see they have given structural isomers having molecular formula C6H10, and then name, none of them show optical isomerism. All 4 isomers, that means there are other types of isomers. So it treated with mercuric sulfate, H2SO4 to give products, react with 2,4-DNP, use colored precipitate. Only A gives precipitate with ammonium nitrate, and A has one position isomer. Right? B is a chain isomer. So isomers, structural isomers can be chain isomers, position isomers, and so you have done the isomerism. I gave a summary. Right? So this is how you get the questions. Draw the structure of ABCD based on this data. And even in A-level 2000, like 1990s to 2000 also, they have given this. So still they are asking this pattern of questions, and then they are asking to draw the do not show stereoisomerism. Name the compounds. Okay, name the compound A, B, C, D. So like that, they ask from the reactions also. They ask, sometimes they give the reagent. Now here you can see above the arrowhead they have given the reagent, and they can ask the product. Sometimes they will give the product and the reagent, and they ask the reactants, right? So that is how you get the questions. And name a test to distinguish, that is chemical test. I'll give a summary of chemical test of all the compounds. I'll try to do it at the end of the reactions. So chemical test to distinguish. So during some organic reactions you get a precipitate or color change, then they can ask that also, right? Okay, right. Then you get, this is the question number 4. And then mechanism type, where is nucleophilic addition, no nucleophilic substitution, there's reaction type. So you should know what type of question you are getting. Can you see here now, within the space provided you have to write. Now again you can see this next part, they have given the reaction and the product, or so final product they have not given, they have given the reaction, right? Now you can easily decide this reaction P, right? Reaction 1, the reagent P you can write, no, you know, you have learned all this, even R you can predict. Okay, this is how you get the questions. Okay, so instead of directly going for this 2020 paper questions, so first I have given a practice paper, the basic questions, more simplest to complex we are doing. This is 2020 paper, even 2019 paper. 2019 paper also they have given the, so my next target is this question, structured essay. Before essay type questions, how to answer this structured essay compulsory question, because it's compulsory and no choice. Here again you can see this is 2019 paper. 2009 paper. They have given both have same molecular formula, right? You can see the screen, right? Yeah. Again draw the structures of like that. They ask questions every year. You get a question like this. Test to distinguish A and B. Chemical test. So they have given the formula. C6 C5H10, no. So it can be aldehyde, no? It can be aldehyde or ketone, definitely. It can be definitely aldehyde or ketone. Right. And then even now you can do this this kind of this question because you have learned aldehyde ketone reactions. No, we did only alkene, up to alkene. Aldehyde ketone reactions we didn't do, right? Yeah. We'll discuss that also. Can someone tell me, did I give the reaction summary of aldehyde and ketone? Only alkene, right? Reactions of aldehyde and ketone have I given? No, only we. No, right. Okay, then after that you can do it. No, okay. So benzene reaction we did. Now this first reaction you have learned here, no? Reaction 1 here. CH3COCl and anhydrous AlCl3. They ask in the product. They give the reactant and the reagent. They ask the product. Not the balanced chemical equation, not the stoichiometry, no calculation. And there's reaction type, mechanism type, electrophilic addition, nucleophilic addition. So you should know what type of question you are getting, right? So then only you know what to study, right? Then no, so therefore my advice, after each subsection you should know the questions related with that in the paper. Then only you know what type of what to study, what to remember. Okay, so that's why actually we targeting that. Now here I have given I have not given boxes here because of waste of your the space in the paper, because when you're getting a printout then like waste of this one time and money. So therefore I have given here some practice questions, simple questions from what we have done so far. I have given some questions in ALL papers from 1996. So I think last week I discussed first two questions, isn't it? We discussed, right? First one. So I had to start with the third question, right? Third question. Have you done this? All this structure is it. All this structure is it. Because A-level papers in 2000, actually they have given question number 3 organic, but in 2020 and 9, so it's become question number 4. That's already difference. Position of the question different, but the same pattern they ask now, right? Okay, let's discuss. If you want, I can now this. The problem is, I think most of these questions you can't post the answer to the chat. That's the main problem. If you have a writing pad, drawing pad, then you can annotate on my screen for the answer, or else you can what to do. You can take a photo and post that to the chat, I think. Then also I can see that. I mean, you can't type the answer. You can share your file or the image or whatever PDF to the chat. You can share, or else you can I can let you to share your screen. I'll let you to share your screen. Then only I know what to explain. Otherwise, I don't know how to. I mean, up to which extent I should explain. That's why, to have an idea. We didn't do. Did we discuss this whole paper? I don't think. We didn't do this whole paper. We did this whole paper, no? Okay. There's one more paper. This one. Sorry. Right. This paper we discuss everything, right? Can someone reply? Okay, Pramod says we did this paper. We had to do the isomerism of aliphatic hydra. Okay. There's one more paper I have given. Wait. Organic questions. This one. Yeah. Yeah, this paper. Sorry. Yeah, this paper. Right. So this paper we discuss, and we had to do this. Yes. Okay. This paper, right. This paper also I discuss, as I remember, question number 1. last week we discussed only the first question, then I told you to try the rest at home. I've done this. So here I have not given again boxes here, but 2012, 13. This is from C7H14, C7H16. So that is from aliphatic hydrocarbon, this question. From alkene, alkane, alkyne. How many of you have done this? ABCR is 3 isomeric hydrocarbons with molecular formula C7H14. Okay, let's see how to approach this question. Right. I will use this white background. Please raise the hand those who have done this at home. Those who have done this at home, please raise the hand. That question number, the remaining questions, at least half of this. Oh yeah, right. Ishar and Tamasha done. Okay. Others found it hard or didn't have time to do. Anyway, I'll explain, because if you have done at least half, then it's easy for me. That's what I'm asking. Yeah. If you have done at least, if you have done an effort, then it's easy. Huh? Right. Anyway, let's see. Okay. Now, when you read the data, you should make a rough sketch of what they are saying. Otherwise, you don't need to. First, you had read the entire paragraph once, and then you can start from where you know. Right? You can you should start from what you know, right? And then you should find a link to the other informations given. That's how you should do it. Now you know what is C7H14. So that is an alkane, and it's a alkane because it's CnH2n plus 2. So this alkane has 3. Okay, so when you read the data, actually in the structure they say you should not use the red pen and Tipex and highlight. But anyway, you can just copy down separately in point form the important things. Right? Okay, let's see. I'll highlight here. This has 3 isomeric hydrocarbons, and the formula is C7H14. So those 3 hydrocarbons are ABC. And the other information, that is one part. And the other one, A shows what? Isomerism. Geometric isomerism. So geometric isomerism is cis trans, no? While B and C won't. B and C won't do not show isomerism. Right? All the compounds exhibits optical isomerism. All these compounds, all the compound means all these are, I will highlight all, and then I will highlight optical isomerism. Right? After that, on catalytic hydrogenation, what is catalytic hydrogenation? So nickel, platinum, nickel low, platinum, you add hydrogen. Hydrogenation, all the compounds, I will highlight all, will give the same product D, C7H. That means H2 is added. So that means C7H14, CnH2n, that should be an alkene. No? This should be an alkene. After hydrogenation, they all will give alkane. That means this D will be alkane. So alkene become alkane after hydrogenation. So this alkene has geometrical isomerism, and one out of ABC, all 3 are alkenes, but only one shows geometric isomerism, and all 3 optical. That what is the most important thing? All ABC optical. All ABC optical, right? Out of all A, so that is, if you get all ABC optical, and out of that only B, only A geometry, only A geometry. That means what? B, only A shows both optical and geometry. Can you understand that? Did you notice here? A optical as geometric both. A shows optical isomerism and geometric both. Okay. So geometric only A. So then all ABC produce same compound, same yield, say 7H16 after hydrogenation. Then compound D, okay, after hydrogenation of all three, I'll draw that this side. When all three after hydrogenation will give the same product D. That means after adding hydrogen, all three give the same product C7H16. That is D. D is C7H16 and that D optical again. So then you have to predict the structure of ABCD. Give the structure of ABCD. That is based on this data you have to predict the structure of ABCD. That means the first three initial compounds, the structures ABC and the final product form D after hydrogenation. It is not necessary to draw the stereoisomeric form. Stereoisomeric form is what? L form and D form is not necessary. Cis form and trans form they are not expecting, right? Cis form and trans form or L and D form they don't expect, but you have to draw the structures. Right. Then how many of you now can you guess, those who have not done, can you at least ABC can you decide? Because formula also there I gave. This is very important. First point I put the left side of the screen and the other side, right side, I put the other most important information. Okay. This is how you get compulsory questions from organic chemistry. Let's see how to draw ABC. Now this is also again I have to tell you because this is structured essay. Therefore you can't do trial and error with the pen. You can't complete the boxes given in the structured essay paper, paper. If you do a mistake you can't erase it, you can't typex it. They don't give additional structured essay paper. So then you have to take a rough paper and do it. Okay, when you get all the structures correctly only you can transfer the final answer to the paper. That also you have to be careful. Okay, now let's see C7H14, that is an alkene. How to write this alkane? So you can write a linear one. Okay, can we write a linear one for this? All the carbon atoms we put like this, 7 carbon atoms linear. Can't. Why? All three are optical. What are the conditions? All three are alkene, plus they are optical. Okay. Alkene, that means there's a double bond plus optical. That means what is the type of isomerism? They talk isomeric hydrocarbon, but what type of isomerism exists in all three? Optical. Here all these compound exhibit optical. Actually that is the first point they should put, but they have put that after giving some other information, geometric thing. A source geometry. All three are optical. A source geometry. A, what is the condition? Alkene. It is geometric plus it is optical. To satisfy all three conditions, you have to draw the structure for A. Do you understand what I'm saying? I write this, but in the exam, no need to write that. This is like, you should have a logical argument here. Logical argument when you can't just draw. If I know the answer, but I can directly draw the structure of A. But then you should know how your mind is working. That also I had to think. So how you can logically argue to get the answer. So one is what? A is alkene. So A C7H14, C7H14. This A is alkene. From the formula, you should know it's an alkene. They have not given that they have not given whether it's alkene or alkyne, right? They have given just the formula. Then second point, it is optical plus it is geometry. Then you can have only one structure because they have not given two boxes for A. They haven't given two boxes for A, only one box. They have given four boxes to write A, B, C, D. Now how to match this A? How to draw the structure of A? Instead of putting a box, I'll write this answer. So can you guess the answer for this A? What type of structures you can draw and you can try and do it? There must be optical means what? There must be asymmetric carbon, optically active carbon. So I'll put this carbon atom at the middle, optically active one. So I have now how many carbon left? 6 more carbon left. 6 more carbon left. So 6 more carbon. I have to make this optically active. That means 4 different groups. And there must be a double bond also. So I'll put here hydrogen. Right. Having that in my head, there must be 4 different groups. So I put this side carbon and this side I put carbon with 2 carbon because I had to make it different. So this side I put 1 carbon and the other side I put 2 carbon. Then there are 2 different groups. There are 2 different groups. 2 different groups. Then how many carbon have I utilized now? How many carbon have I utilized out of 7 now? 1, 2, 3, 4. 4. How many carbon left now? How many carbon left? 3 more carbon left out of 4, out of 7. Then I will put those 3 here. Now here you can see I get 4 different groups around the central carbon. This so to satisfy this optical activity. What is optical activity? If I put again carbon to this side, what happened? Then again I get, why did I put hydrogen here? If I put carbon here, what problem will arise? Then I have to erase this carbon or this side carbon. Then you get 2 similar groups. Then it will not be optically active. Do you understand what I'm saying now? Then this also ethyl, this also ethyl. CH. Then there will be a problem. And the other problem is not that. These two become equal. Then methyl group. Those two become methyl group. Sometimes you can argue, sir, we'll put a double bond here, then no problem. Then these 2 groups will be different. These 2 groups will not be same, but these 2 groups will be equal. Do you understand what I'm saying? That's why we can't put carbon atoms around all 4 sides. We can't put the carbon atom. Is there any question up to that? That's why we put here hydrogen. Okay. Is that clear, everyone? How to get the structure of A? Then we have to put what? We have to make this an alkene. We have to make this an alkene. And that alkene is what? Geometric. Geometric means what? It's cis trans. It becomes cis trans. That means what? It should be cis trans. That is called geometric. If you have even a simple doubt, if you want me to explain any step, tell me again, right? Because my target to do minimum questions and to give this concept to your head to understand. Otherwise, even if I do 100 questions, if you are not getting this concept, no point. I am doing hundreds and hundreds of questions, organic chemistry, but you are not improving. So therefore, my target from minimum, like I will select some questions of each type. Then you can manage the rest. Right. So this is from alkane and alkyne. Now is that clear? Now just to fill the hydrogen, now what is the best place to put double bond? Now that is geometric to make it cis trans. I can put the double bond here. Don't write anything, look at the screen. If I put the double bond here, will I get cis trans? Then this becomes CH2. Then it will not, no cis trans here. If I make bit, because anyway I need 2 carbon atoms to make the double bond. Right? So can I put the double bond here? Can I put the double bond here? Then what happened? I had to, then there will be 5 bonds around the central carbon atom. Do you understand? Around the optically active carbon, this around the red carbon, I can never place a double bond. If I put a double bond, what happened? Then around this carbon there will be 5 bonds. That is not possible. That is not possible. Therefore, what is the most suitable place for the double bond? Between carbon number, this side. There are 3 carbon here. That is the best place to put the double bond. Okay. Then I can put the double bond. Can I put the double bond terminal? No. Then it become what? This side become 2 similar groups. Then no cis trans. No cis trans. Double bond is there. Alkene will be there, but it will satisfy the. So you can have, but I can make isomers by doing that. Now, how this become isomers? By putting double bond at different places, because all 3 are optically active, no? The same optically active compound. Depending on the place you put the double bond, this will change. Depending on the place that you put the double bond, this will be, this will change. Is that clear? So then A is this, then B also I can get easily. Because all 3 are, this is the only optically active compound. Therefore, this will not change. All A, B, C will have the same optically active compound. No other optically active compound I can draw. By changing the optically active carbon, I can't draw 3 different structures. I can't draw 3 different structures. A, B, C. Now you can continue if you have got it like beyond this. If you can easily, now can you place the double bond and make it 3 different structures? Out of the 3 different structures, only one will be geometric. Others will not show geometric, but the double bond will be there. Double bond. So you can change the position of the double bond to make 3 different structures, A, B, C. Got it? Did everyone understand? So this is the first question, is you are doing like kind of complex one. So did you learn? Did you get this logical argument? Please reply. Otherwise, I'll explain further. From again, if you want me to explain, so how did you predict this? Like I am not doing like this magic. This is the answer for this. This is the answer for this. I can finish this. But okay, so each statement logically I got it. I didn't tell this should be like this, so you have to remember that like that. No need to remember. From the data given, I predicted this. I'll give one more example. This is like, now every, okay, let's say I'll say like this. In Sri Lanka, if some people are mostly actually this is what happening. Girls or the ladies, they are targeting the government jobs. Because it's easy to maintain the family with that job. Why? Less stress from the job is stress less. So if you go to private sector, then definitely you get a stress because there's a target, right? You can't just nikang in. So government places say teaching. Majority of the education sector, the ladies, if you take a school, check your school, male teachers or female teachers, more female teachers, right? So then after 1:30 they are at home, then it's easy to maintain the family, look after the kids and all. They are because mother also can contribute a lot to their children, because with them at home, right? So the same scenario the other places also, even or university lecturer or maybe a teacher. So that is government sector. The most of the ladies, they target government sector. Now what happened, there are some girls passing out from maybe their chemistry special degree. I have this experience. They work in a private sector and they get a better salary also, but after a few years, when they get the first baby, second baby, then they leave that job and come to the teaching, right? Government, because of this. Otherwise there's no one to stay with the babies in the house. So they have to find 2-3 housemates. So like so therefore, and they get 3 months vacation. Right now, now imagine this COVID situation. Who is mostly at home out of all the professions? Teachers, no teachers, right? From last year March, I think maybe like less than 3 months they were in the school, government schools. I don't know, your school the teachers are doing online now. These days the government school the teachers are not doing even online. Yeah, is their salary deducted? No, they are getting the full salary and they are at home. But it's not a big salary. They are at home. Right now, and after 20 years they get the pension also. Right, they get the pension also after 20 years service. Right? And by age 50 they can retire. By age 50 they can retire, the ladies, but male teachers, government school teachers, they cannot retire. They have to stay until age 55. So some of the teachers, they are getting nearly 1 lakh pension, like if those who have the service more than 20 years. So that's why this okay. Now I am telling, to come to this, they have to do competitive exam, Taranga Vibhaga, government, the Department of Examination, not only for A level and O level. So per month they are doing grammar sevak exam, custom exam, and then administrative exam, SLES, Sri Lanka Adhyapana Paripalana, then those who are the secretary of the ministries, and they all come from this. You can see these days COVID-19, that health directors of the provincial health directors, MOH, for all this there are exam for the recruitment. So what is the main requirement? They should have a degree accepted by the UGC. It can be open university or that university, whatever. In Sri Lanka there are nearly 16 universities. They have to do a degree. Now in these competitive exam, so they get a IQ paper and language, and there are about nearly 3 papers most of the time. So those who score good marks, they get selected for that job, right? Now in those who are doing A level science and maths, they perform very well in those exams. Right now, if you take in most of the places, even in central bank, even BOC, like public banks also, like mostly who are performing well, A level, those who had a max, not commerce, those who had an A level max, they easily go to the, they do SIMA, SIM and all the professional qualification also they get there, and they go to they get promoted easily than the other people, right? Even few of my friends, they had an A level bioscience, now he is the bank manager, right? One has done A level max, and now he is central bank, top of Asia, right? Now that is because of this IQ exam, they perform well. Those who have done arts and commerce, they pass the language paper, but IQ paper they don't pass, because minimum you have to get 40 marks, right? Each paper you have to get 40 marks or above for this. So now what is the main eligibility to sit this exam? Having a government degree. Government degree means government UGC accepted basic degree. So there are various services now, Vidyatmaka Sevaya, right? Scientific service. So those who are like, there are people like that. Right, anyway, to become government analyst, Raja Rasa Parikshaka, you can join the government analyst department, Raja Parikshaka department. So what is the main requirement? You should have a degree from science. So they will consider some subjects, right? Those who have done these subjects for the degree, then they are eligible to sit that for that exam, right? Harbor, custom and all, right? Now I remember this when I discussed this question with you. You get this type of questions not from chemistry. Kamala Vimala Sumana sit in this order, and that, like, IQ papers, no? So like that. So then the max and bio students, they perform very well this exam, right? So this is a good practice for that also, right? Not only for the A-level chemistry paper, right? Now so up to this, are you all okay? Right? This is the only optical isomer I can draw. So all 3 are optically active. Right, I put here all 3 optical. Green one, look at the green one. All these compounds optical isomerism. These are only optical isomerism for all 3 I can draw. But how they are differs ABC from the geometric? No, geometric means what? Having cis-trans isomerism. Cis-trans isomerism. But out of this geometric thing also, what? Only A is geometric. They have given B and C not geometric. Only A geometric. Okay, I'll write that also here. Only A geometric, B and C not geometric. No cis-trans. Not geometric. This also not geometric. Now where to put the double bond in the first one? A only geometric. So that means there must be cis trans. That means two different groups are attached to each carbon atom around the double bond. I told you, here I can't put the double bond. Here number 2 I can't put the double bond. Number 3 I can't put the double bond. Because if I put here around the red carbon double bond, then there will be 5 bonds around the red one, asymmetric carbon, optical active carbon. That's why. So that place I will put 1 and 2, I had to erase. Then the next place available is 3. If I put 3 here, then this to become hydrogen hydrogen. Then is no cis trans. Double bond is satisfied. You get the correct formula, but you will not get the cis trans. To make cis trans only possibility, I have to make the double bond here between what? These two carbon atoms. If I put the double bond in the terminal carbon atom between these two, will I get cis trans? No, because again this side becomes CH2. If there are two similar groups attached to this carbon, double bond carbon, then there won't be any cis trans, right? Okay. So then I'll complete now. Now rest you can do what? Add hydrogen to make 4 bonds. CH2, here CH3, and here CH3. Around each carbon add 5 bonds. Add hydrogen to make 4 bonds around each carbon atom. So this will be, then this will be CH, and this will be CH2. Now this around the double bond there are two different groups. How this become 2 different groups? Sorry, not that carbon. The double bond I had put here. Sorry about that. I'll put here the double bond to make it geometry. So here the double bond. Then this become CH2 and CH3. Right? CH2 and CH3. Right. Okay. When you write this carbon atom, leave some space to write the hydrogen. Otherwise, again you have to erase. You have to leave some space between the bond and the carbon to put the hydrogen. So this is CH. Right. But anyway, they have given within bracket, not necessary. I'll highlight that it's not necessary to draw the stereoisomeric form. Stereoisomeric form, no need. So this is CH, no? This is CH. Right. So this is the structure of 4A. How many of you got this structure? Please raise the hand. Before I explain those who got this structure A like this, please raise the hand. None of you? Who got this structure, capital A, the structure for A, geometric and optical active? Before I explain, did anyone get? No. Please raise the hand those who understood this. I mean, structure A, how did I get the structure A from the data given? Ishara, you have any doubts? Okay. Ishara, did you get it? Because all three raise the hand except okay. Sir, can you explain cis trans again? Okay, good. Okay, Ishara is asking, sir, can you explain cis trans again? Now cis trans means, okay, cis trans, this is how you get it. There's a double bond here. Around this double bond, this side you should have 2 different groups. That means here you should have, what is the look at this double bond. I'll expand this. Hydrogen, this side hydrogen, that side CH3, and here you have a carbon. Here around this also, this side hydrogen, and this side this entire thing. Entire thing means carbon, this entire group. I'll put that instead of drawing, I'll put here that this should come here. This entire thing come this side here. That is this carbon. That means here hydrogen. Okay, if you want, I'll draw it. That means this side hydrogen, this side CH3. CH3, and here you get shall I put C2H5? The same thing. I'll put here because I don't have space. I'll combine these two and write as C2H5. Okay, right. Shara. Now what is this? This is the cis form. This is the cis form. This is the cis form. Now if why this becomes cis? This side hydrogen, and here you get the other side you get CH3. So there are two different groups attached to that carbon. This side also what? This side hydrogen, and this side you have different group. This entire thing has one group. Okay. Then if I switch either left side or right hand side, if I change the groups up and down, then not both. If you change both side, then it will again it becomes 6. If you turn this by 180 degrees completely up and down, both the hydrogen will go down. Again it becomes 6. So only one side you have to change. Then it becomes the trans. Okay, is that clear? Is that what you asked? Did you get the answer? Okay, right. Then okay, that is the cis one. Okay, that is how it shows cis trans. Okay. Then B. So no geometric. Now same formula, C7H14 for all three ABC. C7H14. Now I can make B and C. I can't break the double bond. Sorry, I can't remove any carbon here. I can't delocate again, or I can't redistribute any carbon atom. I can't change this carbon skeleton. Why? This is the only optical I can draw. I can't draw any optical isomer other than this. All three are optical, then all three having this skeleton. So how they differ? From the position of the double bond. So then if I now B and C no geometric, then I will shift the double bond to here. I'll put the double bond to here. I'll put the double bond to here. And then next one, if I want, I can put double bond here, no problem. If any one of you put the double bond here, that also no problem. Okay, either place you can put the double bond. So I'll put here, and then for this one I'll put the double bond here. So they are now all three are alkenes. All three are optically active. All three are optically active, but B and C no geometric isomers. Why? This side CH2, there are two equal groups. Here also there are two equal groups. That's right. So others you can fill the hydrogen. So this is same as earlier, CH2, this is CH3, this is CH3, CH2, CH2, here CH, here CH3. Okay, this one CH2, no? Yeah, here CH. Right, is that clear? So B and C. Now B and C what? Alkene. There's a double bond, but no geometric, because double bond is at the terminal. In both B and C, double bond is at the terminal. Then if the double bond come to the terminal between the terminal carbon atoms, then it will not show cis trans. But optical activity is there. Optical activities they are in all three. Okay, any questions now? This is how you get ABC. Now if you all three, if you do catalytic hydrogenation, then you get the same formula C7H. All three will give the same compound D. All three will give the same compound D if you do the catalytic hydrogenation. That means double bond is broken down, then you get two hydrogen is added around the double bond. So I will draw that also. Now what is the next one? We have to predict the structure of D. Structure of D. How to predict the structure of D? Okay, I'll erase the rest now. Right, can see the screen. So all three will give the same structure on catalytic hydrogenation. All three will give the same structure after catalytic hydrogenation. That means you add here hydrogen, nickel hydrogen, catalytic hydrogenation. Then you get what? You get the same structure, the same skeleton again, no? Skeleton won't change. Then here what happened? The first one, hydrogen goes to this carbon, then this becomes CH2, CH2, CH3. And this side it becomes CH2, CH3. Right? And the other side it becomes, this side anyway hydrogen, hydrogen. So here you get CH2, CH3. And this side you get CH3. Okay. This is the same structure. So therefore what happened? In a compound, this place become hydrogen is added. To the other compound, here hydrogen is added. H2 is added. So the other one, this corner hydrogen is added. So these are the three places hydrogen is what? 1, 2, 3. So these are the three places where hydrogen was there, double bond was there. So in all three places, H2 get added. Then you get the same structure from all three. Is that clear? So this compound is again optically active. This is the structure of D. All three will give the same structure D. This D will be again optically active. That's what they have given. D is optically active. Compound D also optically active. This is optical. Okay, please raise the hand those who understood the structure D, how the structure D is, how did we get the structure D after hydrogenation, catalytic hydrogenation? Right, very good. Okay, so D is optical. Now this is how you get A, B, C, D. Now to get these four structures correctly, you should know the reactions, isomerism, chemical formula, right, everything about alkane, alkene. Alkane, alkene, that is called like, there's something called space intelligence. What is this called? Avakasha buddhi. Now we have nearly 9 intelligence. Actually in the exam mostly they test 1 intelligence, right? I mean social intelligence, like sometimes some of the become, now those who are doing A-level maths, sometimes they do architecture, right? That means country planning. They can decide, they can have the entire, maybe the city, the plan, they can create mentally. They have that picture in their head, and then once the city is built according to that plan, so they get the same image. They draw image for that image will be the real image after building that city according to this architecture. That is those who have the space intelligence, avakasha buddhi, right? So therefore that also should improve when you are doing this resonance and Lewis structures and resonance Lewis. In addition to that, this isomerism and geometrical isomerism, geometry, arrangement of the groups in the space, no? Yeah. And the other most important thing, you can see, you can imagine if we are struggling to answer this type of question this much logically, you can imagine the person who said this question, how it's difficult. If we had done a simple mistake here, what happened? He has to give free mark for all the students, no? So setting a question is more difficult than answering. Remember that, right? Okay. Okay, shall I erase the ABCD? Then there's next part. Next part they have given. I can't show the question now. You have the question, right? You can open your the PDF, or else I can erase it. But it's this next question also linked with this. On treatment with bromine followed by dehydrobromination with alcoholic KOH, A forms 2 compounds E and F. Okay. A form 2 compounds E and F, while B form compound G, C form compound H. All 4 compounds have the same chemical formula, C7H12. Compound E shows geometric isomerism. FGH do not. E shows geometric isomerism. Right. give the structure of EFGH. Okay, let's see. I'll draw this, I'll erase this one again. Okay, this is the rest now. What is bromination? Add in bromine. What is dehydrobromination? Removal of bromine. Removal of bromine. The next part I am explaining now. Right. Look at the screen. So they have given on treatment of bromine. Treatment of bromine followed by dehydrobromination. You add bromine and then remove HBr. How? By putting alcoholic KOH. By putting alcoholic KOH. Now let's see for this one. A. Okay, I'll use reduce the line thickness, otherwise I don't get enough space to draw this. A, you add bromine and then remove bromine. I'll draw this side. You add bromine and remove bromine. That is called highlight the word bromination. On treatment with bromine, you add bromine to A. To others also you add. What happened now? CH3, then you can decide the structure of CH3CH, then HBr get added here. This CH, CH, CH3. So here the Br is added. Br, 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 Br. Then this side you get CH2, CH3, no change. Right. Here Br, here also Br is added. Can you see the screen? Yeah. Double bond is broken down, Br is added. Now you again remove this HBr. How? How to remove HBr? You remove HBr from this. If you remove HBr, how to remove HBr from this? That is called dehydrobromination. Dehydrobromination. Then you get two compounds. Then you get two compounds. Two compounds. Removal of HBr by adding alcoholic KOH. Look at the question. Alcoholic KOH. When alcoholic KOH is added, HBr is removed. Then you get the two structures. How do you get two structures? How do you get two structures? So those two structures they have given E and F. A form two structures E and F. E and F. Now you have to predict the structure E and F. So one possibility, HBr can be removed from this side. This Br remove hydrogen from this side. Because you get both has the same formula C7H. What is the first structure? C7H12. That means again you get alkene. This also has C7H12. The same formula, both has the same formula. Both come from the same reagents. Alcoholic KOH and Br2. Bromination followed by dehydrobromination. For the dehydrobromination, what is the reagent used? Alcoholic KOH. That means HBr is removed. Can you please highlight in the question dehydrobromination, dehydrobromination, put an arrow and write. Okay, if you want, I'll show the question here. Okay, can you write here, put an arrow towards this dehydrobromination right here, removal of HBr. So if you don't know the meaning of these terms, then also problem. Dehydrobromination is what? Removal of HBr. Can you please write it? Please write here, dehydrobromination is removal of HBr. For the removal of HBr, what is used? Alcoholic KOH. On treatment of bromine means what? Addition of Br2. First you add Br2 and then you remove HBr. Then A gives what? Two compounds E and F, and B gives G, C gives H. From each of the other compound you get one compound per each compound, but only from A you get two different compounds. and all four having the same structure C12. That's all you are given. All four having the same formula C7H12. Okay, so you have to highlight the important keywords in the question again. Okay, then again, okay, let's see now. Can you guess what would be the two structures for E and F? From A you get E and F. From compound A you get E and F, after in Br and Br2, and then removing HBr. So HBr can be removed in different ways. See, you can't make a alkyne here. If Br goes from this side and the other one you can get from this side. Each bromine will take hydrogen from the adjoining carbon. This hydrogen is removed and here one of this hydrogen is removed. Then you get what? Let's see the structure E. I'll draw the structure E. So again, that connectivity no change. Carbon position won't change. Carbon position. So this hydrogen is going out. No, this hydrogen will get erased and you get a double bond here. You get a double bond here. And you get here CH. And the other side you get again CH. So this CH2 no change. I'll highlight that. This CH no change. This CH no change. That CH no change. Okay. Here no change. These two no change. Because that hydrogen retained. Bromine goes with the adjoining carbon hydrogen. Bromine will take away HBr to form HBr. Bromine combined with adjoining carbon hydrogen. Adjoining carbon, that means to the right side one and left side one. Then this become again double bond is formed here. That becomes CH2. Right? CH2, because CH3 becomes CH2, removal of hydrogen from that side. This side the upper hydrogen, that optically active compound, upper hydrogen is removed, and this side CH3, and here you get CH2, CH3 will be left as it is. That is E. That is E. That is the structure E. Okay. So see whether is C7H12. C7H12. See whether is valid. C7H12. Actually, this is alkyne. That means C7H12 means what? There must be 2 double bonds or 1 triple bond. This is CnH2n minus 2. No? CnH2n minus 2. Ne? That means either alkene. Look at the formula. C7H12 means 7 times 2, 14 minus 2, 12. So that is an alkyne. Alkyne, that means 1 triple bond or 2 double bonds. 2 double bonds. These are the possibilities to have the common formula CnH2n minus 2. So that is the answer for E. Is that clear? Do you want me to explain again this one? I highlighted that one. Then the other one, the other possibility is this Br, I'll draw the next one. This Br can remove hydrogen from this way. Alternative, like say this Br will goes with this hydrogen and this Br goes with the other hydrogen next to that. That is also possible. Then you get a triple bond. This is a really a good, very good question. I think Professor Gunawardena and Professor this, I think 2000 in 2000 to 2010 they only the chief examiners. Right, CH3 C H, this side CH2 CH3, and here you get CH3, here you get CH, here you get CH. This become what happened? This hydrogen is also going out, this both the hydrogen going out, and then what happened? Just only carbon, no? Then you get a triple bond here, single bond become triple bond. Right? Okay, so 2 HBr going out from these two carbon, then you get a triple bond, and here you get CH3. Now this is also C7H14. This is also H12. Sorry, H12. Is that clear? Is that clear, everyone? How do you get this structure ENF. ENF. Any questions? Or do I need to explain this again? Please raise the hand those who got ENF. From A you get ENF. How? By bromination and then dehydrobromination. Adding Br2 and removing HBr. There are two different ways HBr can be removed. From A you get ENF. Please raise the hand those who understood ENF. C7H12 both ENF. From the same compound A it is formed. Pramudi and Vinhara, any questions? Any part did you miss here? Or did you get it? Pramudi and Vinhara? Okay, Pramudi, yes. Okay. Vinhara? Right, okay, done. Right, good. Okay, then from A you get ENF. If you have a simple doubt, tell me only this part. Could you explain again? No problem, I'll explain. Because if you don't get this, then that is the end of the rest of the questions also of this type. That's why each whatever the question I discuss, I'll explain that in detail, even though it takes time. Otherwise, even if I do a lot of questions from organic chemistry, you will not improve, only I will improve. Right. Then how to get, okay, so you are doing the same thing for B and C, no? Now B and C you can easily get the answer. Now without my help, but you add Br2 and then remove HBr. Add Br2 and then remove HBr. So from B, if you add Br2, what is the structure? But anyway, in the exam, they are not asking the intermediate one. After adding Br2, the structure you get, they don't ask, right, in the paper. They don't ask that in the paper. So I'll write here CH3, CH, then you get CH2, CH, here CH2, and here you get Br, Br. Here you get Br, Br. Here you get Br, and here you also you get Br. Okay. Adding Br2 and removing HBr. Then you can get, this side you get what? CH2, CH3. Right. Then when you remove HBr, you can get the structure G. From B you get a structure G. B forms compound G. Right. So I will highlight bromine and bromine. So you can have a triple bond here. You can have a triple bond here. How? How come triple bond? This Br goes with this side hydrogen. Right. And this Br goes with the other side hydrogen. This Br goes with this side hydrogen. This Br goes with this side hydrogen. Okay. That's how you get it. Then I will write here you get CH3, CH, CH2, CH3, CH2. Here you get a triple bond. That means 2 hydrogen and 2 Br. So this Br goes with this side hydrogen, and this Br goes with this side hydrogen. Now remember, when removing HBr, this is very very important. Look at the screen everyone. When removing HBr, bromine and hydrogen will not be removed from the same carbon. From the same carbon, both HBr, both bromine and hydrogen will never happen. Br from one carbon, hydrogen from the adjoining carbon. This is also very important. Some students, they pull the hydrogen out from the about 2-3 hydrogen carbon atoms away. This bromine cannot take this hydrogen. Can't. This bromine cannot go and take this hydrogen. Always from the adjoining carbon. From the adjoining carbon. Is that clear? Right. Then next one. Now in the this earlier I told you this B and C can interchange. Okay, B and C could be interchanged, because if you want you can draw C first and then B second, then the order will change. B and C can be interchanged. Accordingly, the G and H also can be interchanged. So this is a structure for G. This is a structure for G. Right, G. Right, this is the structure of G. And then we have to get the structure H. Okay. So again, C also we are doing the same thing, but add in Br2 and then removing HBr. Add in Br2. So all these what? Alkenes reaction, no? Nothing new. They have not given any aromatic. So when you add Br2, what happened? Hydrogen get added to this side, CH, here CH2, here you get Br, and here you get Br. And then you get C, this side CH2, CH2, CH3, here hydrogen, and here CH3. When you remove HBr, what is the structure forming again? You get here C, here you get H, CH3, here you get a double bond. So triple bond, here you get triple bond, C, this one CH. Exactly, I think it's not space to draw it, but anyway, I'll quickly draw it again. Get here C. I'll draw with a different color. C. Here this side CH3. Here you get carbon, triple bond, CH. And then this side you get CH2, CH2, CH3. And here you get hydrogen. What is this? H. The structure H. So here the triple bond in this one. Triple bond here and here, and it's here, and the other one, it's here, the double bond, and it's become Br2 here, and here it's become triple bond. Okay, add in Br2 and removing HBr. To remove HBr, what is the reagent used? Alcoholic KOH. Alcoholic KOH. Alcoholic KOH. Now sometimes you can ask, why can't we remove geometric isomerism? Compound E shows geometric isomerism. Compound E shows geometric isomerism. Yeah. Now compound E shows geometric here again. Which carbon is geometrically active out of this compound? Look at this your description given in the question. All four compounds are having the same chemical formula, C7H12. Compound E shows geometric isomerism. That means what? Compound E, this is in E, this is geometric. This shows geometric isomerism. This is geometric. That means it has cis trans. This one has cis trans. That also valid here, right? That is also given in your description. Because of which carbon is cis trans? Not because of the terminal double bond. Due to this double bond. Due to this double bond, it shows cis trans. Cis trans. Okay. Now sometimes you can ask this question also. So why can't we take hydrogen from the others? Now this Br, there's a chance of removing hydrogen from this. Then you will not get the adjoining, very unstable if you have a double bond like this. Carbon dioxide is possible like oxygen, but this is a bit unstable, that compound. That's why you can't go for that, right? So now we got the structure for E, F, G, H. E, F, G, H. Any questions? Is that clear? E, F, G, H. So they say that E is geometric isomerism. So won't it be a problem if there are two hydrogens on the terminal atom? No. It is okay. Who asked that question? Pramodi. Now, because this entire, okay, I'll draw this. Shall I erase the other part? Because Pramodi is asking how this E become geometric. I'll draw this side. I'll erase. This is how, Pramodi, this E become geometric. I'll expand and show you. Then you will understand how E become geometric. There are two double bonds. So actually out of this, because of one double bond is become, not because of both the double bonds. If I draw the cis transfer this E, if I draw the cis form, it will be like this. Because of this side, this is CH3. They don't tell with the cis transfer. This is actually CH2, CH3. CH2, CH3. Shall I put that as C2H5? Then it's easy for me. I'll combine this and put C2H5. Okay, then you can understand C2H5. And this side you get hydrogen. Look at here. I am taking this double bond. I have put a star here. That one. I have put a star. That one. So I'll put a star here also. Then you get this side H, and this side you get entire thing as CH double bond CH2. Okay, this is how you get it. But actually there are four different groups. No, you can't name this as cis or trans, but it shows geometric isomerism. And you can draw the other structure by changing one side up. You can change one side up and down, and then you can get the other structure. Either left side or right hand side, you will change it. Try this. You can change this side. I'll keep CH3, C2H5 like this, and double bond. Here I'll take CH double bond CH2, and here I'll get H. This is the other structure. But you can't take this, you cannot name this as cis trans. But why it is geometric? What is the main requirement for geometric? There are two different groups attached to this side, and this side also there are two different groups attached. That is how it become cis trans. Okay, so these two are different. But horizontally no need to become different. Horizontally they can become equal, but vertically up and down they should be different. On each carbon there must be two different groups attached. What is the requirement? On each carbon there must be two different groups attached. So this is different. This is different. This is different. And this is also different. Okay. That's how you get this E get geometric isomerism. So I told you earlier, some geometric isomers cannot be named as cis trans. That you should know. Okay. All the geometric isomers are not showing cis trans. Please write that with in your short notebook with a red pen. I'll put a stand right here. What is the requirement? Okay, even if you take carbon, say fluorine, chlorine, bromine, hydrogen. So this shows geometric. Why it shows geometric? There are two different groups attached to each carbon. Each carbon, two different groups. So then vertically they are different, no? Vertically they are different. Horizontally they can be equal, but here horizontally also different, vertically also different. So it's geometric, but no cis trans. But cannot be named as cis trans, but no cis trans. That is very important. So therefore, what is the general statement we can give now? All the geometric isomers are not showing cis trans. all the geometric isomers are not showing cis trans. Actually, you can learn theory also from the questions, right? Then that theory you will remember, because from a problematic situation you come up with a solution. That will become again a theory node. But if you directly write theory without problematic situation, that's what we are doing. Without facing any problematic situation, you just write the theory node. But the problematic situation come in the exam. Therefore, my advice, if you can do some theory part with the problematic situation, then that is called the new method of teaching. The other countries, that's how they are going to implement 2023 onwards in local syllabus. 2023, now this A level will be in December and O level will be in August. So grade 1, 6, 8, grade 1, 6, 8, 10 and then 12, I think. They are going to change 2000, these grades, grade 1, 6, 8, 10, yeah. They are going to change in 2023. So then this grade 10 students, they are doing A level, grade 11 in 2024. And they will be doing A level in 2026 if you have any younger brothers or sisters. So they will be getting this new syllabus, grade 11 in 2024 and grade 10 in 2023, right? So for them, actually they don't directly teach the product or the abstract or the content based part. They will give a problematic situation or authentic scenario, and then based on that they have to develop that. Automatically they will learn it by doing it. That's how you get it. That's what happened in your day-to-day life. Now in our day-to-day life, everything is not the before the solution. The problem is in your head questions. Do you get different in your life? After married, no. Before married, no. After having children, you get some problematic situations. So you have to come up with a good solution for that. Right? Good solution, so that everyone will be satisfied with that your solution, not only you. Otherwise, then also there's a conflict. So you get that experience also from this subject, by learning these kind of subjects. But here the traditional method, you will first learn the product and then you get the problematic situation only the exam. Now new method of teaching, you are given a question to your head, then you explore. Different students will come up with different solutions. Sometimes that solution will be more smart than the product you learned before, right? The content. That is what they are planning now. That is why if you want, you can check in the internet. Even most of the scientists in the world, including Albert Einstein, right? I think there's a scientist, he was dropped from the school. He is not I can't remember that person, maybe Thomas Alva Edison, right? So then mother has given him good advice, so he is dropped from the school, and then mother has been he is too smart, so that is he is not to stay in that grade or something like that. You can check the story. Then he became a scientist, and they have not got a degree, they have not got the formal education. Most of the scientists, most of the discoveries that has happened at age 40, at age 50, when they become old, not at young age, right? Some of them may be young age, but that is without going to a school, without getting a formal education, without getting a degree, right? So most of the innovations in the world, innovations. Therefore, that means they observe a problematic situation in the nature and they come up with a good innovative thing. No one else has, because now you don't come out of the well, you are inside the box. You play with this subject, that content, this content, targeting, memorizing that and repeating the exam to get the degree, right? But the other people, they are not confined with this, limited to this content given them. They go beyond that, they think out of the box. So you have to come out of the box sometimes to give a new product, new innovations to the world. So those people, they become a new invention, right? Most of them like that. Scientists, there are a lot of example of examples I can give those scientists, including Albert Einstein. Okay. I think some of them, they were like from the small, they, because of the economical issues, they were selling the stuff, newspapers and all in the train, all like different papers. So they were, while they were working there, their curiosity, and that is they are those who observe the nature, they learn faster than those who are looking at the text in the news, this one in the books. That also remember, right? That's why most of the students, those who are coming from the rural areas, even this in athletics also, they perform better than this in Colombo. So hardworking, they are hardworking people. You can check even the even lecturers in the universities, professors, and most of them are from rural area. Even if you go for the island ranks, even Royal, Anand and Nalanda, so those who have come from the rural areas from the school, the after grade 5 scholarship exam or after all the results, right? If they were in those schools, then the credit will go to those schools for the yellow results. But anyway, the top school, they will gather from all over the country. The most, the top students after scholarship exam, then Devi Balika, Vishaka Anand and all the Royal, they will get these people, right? Even now, some of you are in the international school. Now you join after A level, you can join to a good school, and then that credit goes to that school. But if you are in your previous school, then that credit will definitely will be in that school, right? For your good grades or the results. That happens, I think, art stream once in the Lyceum, right? In a few years back. But after that, now they are putting privately the private address, not the school address. For then credit won't go to the school. Then your home address will be in the exam, the result sheet, right? Okay. Is that clear now? This question I took a bit more time, because if I did this in a hurry, you think isomerism part is difficult, and then that is the end of your organic chemistry structure essay. So therefore, to make it, I did my maximum effort to make it easier, to make it simple. But if you need any more explanation, any part if you miss, then tell me, right? Because first at the beginning I will be slow, but later we can speed up. First you should learn the right thing, correct way, and then you can think about the time. Shall we move to the next question? Then shall I erase this? Right? Any questions? They say that E is geometric isomer, so won't it be a problem if there are two hydrogen atoms in the terminal? Now, did you understand that, Pramodi? This will terminal atom hydrogen means double bond. You have to consider. So you asked that question before. So these two hydrogen. So around that carbon, these two carbon atoms, so no problem, because this is terminal very like further away. This one, these two hydrogen, no, it's not a problem for the geometric isomerism. Okay, so what matters here? We are concerned about the carbon atoms around the double bond that I have put a star here. That one. So that one, the two carbon, each carbon has two different groups. Now this one we are not bothered. This entire thing is one group. This entire thing is one group attached to the carbon we are interested. Understood, Pramodi? Yes. Okay. Then shall I erase this? Okay. If you want, I am uploading all the previous videos to the YouTube channel. I will give the link of that channel. Now exam. Now you will forget this after 6-7 months. Again you feel if I can listen to that sir's explanation again, that would be better. Then imagine when the all A-level exam is closed, when you are doing the papers again. So then you can, I will put that under this title. So you can refer your, you can watch that recording again, because Zoom cloud recording will not be a maximum about 3-4 days because of the storage. Then it will automatically get deleted. Therefore each class, the recording I'll be uploading to the YouTube channel, then you can watch it. But please send me your email address, because if I make it private, then other outsiders cannot watch. That's why, right? Then let's move to the next part in the question. Okay, what is the next one? Give one chemical test to distinguish F and G. F and G, one chemical test. Okay, who can give me F and G, one chemical test? What is the structure we got for F and G? F and G, there's a triple bond, and the other one, okay, let's see. Let me draw F and G. You have the answer with you now. So the F and G, the structure, I'll quickly draw it. If you got this one, right? CH3, CH. Here you got triple bond. Then G you got CH3 CH CH2 C triple bond CH. Here triple bond CH, and here you get CH2 CH3. How to distinguish? Who can give me? Okay, you can pause even to the answer. This is the, what is the difference between these two? So here the triple bond is in the middle, and here the triple bond is in the terminal. What is the chemical test that can be used to distinguish? Most even 2020 LL paper also they have asked a question, chemical test. So in some chemical organic reactions you get a observation, clear, physically observed, maybe precipitation, color change, something like that. Yes, any volunteers? So what is, how to distinguish F and G? What is added to this, and what would be the observation? That's what they ask. Yes, you have done this. Can you remember the acidic hydrogen reactions? Any volunteers? You can pause here. So what is the difference between this? This one has acidic hydrogen. This is called acidic hydrogen. What is this? Acidic hydrogen. But this one no as such acidic hydrogen. What is acidic hydrogen? If there's a hydrogen atom directly attached to the triple bond carbon, that means this hydrogen is more acidic than this. This is not acidic, because here the hydrogen is not directly attached to the triple bond carbon. Here the hydrogen is directly attached to the triple bond carbon. That's why. What is the chemical test? Look at the reactions of alkynes. Very good. Pramodi given, add in Cu2Cl2. Yeah, ammonical cuprous chloride. Cuprous chloride. What are the other tests that can be used? Others? Look at the chemical reactions of alkynes. Today I'll give you some identification reactions to distinguish the stuff. I'll give you today a summary. So any others? What would be the? You can put silonitrate and ammonia, or we call it or silonitrate and cuprous chloride. Cuprous chloride, Cu2Cl2 and ammonia, or silonitrate ammonia. One of that you can put. Even you can put sodium. Why? Sodium will react with this one. Precipitate will form. Precipitate will not form. So here you can add ammonical silonitrate. Ammonical silonitrate. Or you can write within bracket ammonia, aqueous and silonitrate. Here also you can put ammonical silonitrate. From which one you get a precipitate? From the one with ammonical. If you want, I'll write the product, but in the exam they have given just the method only. No need to write the product form. Ammonical silonitrate. So what is the product form now? Product form will be like this. CH3 CH C triple bond C. This side no product. This side no precipitate. This side no precipitate, because no acidic hydrogen. This side you get a precipitate. White precipitate will be formed. I put PPT, precipitate. What is the structure of this white precipitate? CH3 CH CH2 CH3 CH2 carbon triple bond CAG. This is the white precipitate form. Is that clear? Pramodi has given cuprous chloride. That also correct, Pramodi. If you add ammonical cuprous chloride, that also accepted instead of this. If instead of this you can put ammonia cuprous chloride, ammonia CuCl or Cu2Cl2. That also accepted. Then you get again the same scenario. Only from the one with acidic hydrogen you get a precipitate. But what happened, even though your chemical test is correct the answer, but if your structures F and G, they have given a condition in the marking scheme, if F and G the structures wrong, no marks for the chemical test. If your structures of F and G wrong, you will not get marks for the chemical test, even though the answer is correct. Other than that, there's one more possibility you can get here. If you add sodium into this, so you will get hydrogen gas, because it's become hydrogen get replaced with acidic hydrogen get replaced by sodium. Acidic hydrogen will get replaced by sodium, but the other one, it doesn't react with sodium. Is that clear? Don't you have these chemical reactions of alkynes with you? You have copied down this. In your summary also, I gave the observation also separately. In your summary note, I mean the alkene summary, reaction summary. In some reactions, I gave the observation because it can be used as a chemical test. Observation means through whatever you observe through your physically, I mean through your naked eye. Okay. Done? That is the end of this question. So it's a good question, no? Shall I raise this? Anyone still coming down? Please raise the hand. Ammonical silver nitrate means you ammonium hydroxide mixed with silver nitrate. Then you get ammonical silver nitrate. Okay. Then next question. I'll erase this. Next question. Question 2013 A-level. Okay, something similar to that. Can you guess this one? So 2012, then the similar one they have given C7H14. Compound A, again it shows optical isomerism. A, which are not enantiomers of each other. Draw two possible structures for A which are not enantiomers of each other. That means you can't do L and D. You can't take L and D as the true structure. Two different optical isomers. Two different optical isomers you have to draw. What is optical isomers? Having a chiral carbon, optical active carbon, asymmetric carbon. Yes, shall we quickly do this one? This is with that previous knowledge you can do it more. If anyone, any volunteers to share the answer, if you want you can annotate on my screen, or if you want you can take you can share the answer to the chat, I mean as a file. Compound A exhibits optical isomerism and has the C7. That's all, no, not much data. Draw the possible structures for A which are not enantiomers of each other. Please raise the hand those who have done this question. Those who have done this, please raise the hand. None of you? Hard. Right, okay, let me explain that. Okay, let's see how to draw two different optical isomers. Previous and all three having the same skeleton. Now you should draw two skeleton for C7H14. Right. How do you now 7 carbon? I'll put 1 carbon at the center. Look at the screen, everyone. Don't write anything. Okay, how to convert this into optical active compound? Okay, optically active compound means what? There must be 4 different groups around the central carbon. How to make it 4 different groups? After putting 1 carbon at the center, then how many more carbon left? 6 carbon. Then I'll put this side 1 carbon. This side I'll put the other carbon. 2 carbon I'll put here. And this side, how many more carbon left? 3 carbon here. Here hydrogen is alkane, no double bonds, no triple bonds, only alkane, only carbon, single bond. So look at the screen, everyone. Here 3 carbon, here 2 carbon, here 1 carbon. Then now altogether what? 6 carbon with the central at the one at the center. Then it will be altogether 7 carbon atoms. So I had to put hydrogen here because if I put here also carbon, then you will get two equal groups. If I put a carbon atom here, what problem will arise? I had to reduce carbon from here or here. Then again you get two CH3 groups. If I remove this carbon, then you get these to become equal. Okay, CH3, CH3. Then no optical activity. You understand? Now there's a very close relationship between this one and the previous one. 2012, I think more, if majority of the students, if they fail to give the correct answer for some past paper questions, they will repeat that again by changing the data. Slightly they will change the same concept, they will repeat in a different format. So that is observed in last few years papers also. Now can you continue the rest? Can you guess the other structure? Any possibility of change in this? Now I had to draw two optical isomers. Draw two possible structures for which are not enantiomers of each other. Now the previous one and this one, what is the difference? Previous one there was a double bond, no? Double bond. But here no double bond. This is previous one C7H14, this one C7H16. Previous one there was a double bond. But here we don't need to put the double bond. Okay. Then what is the other structure? I can draw like this. Yeah, the same formula. I had draw one more optical active compound. Without changing this, how can we change? This side we can change. We can change the arrangement. I will draw like this carbon to this one. I'll put this way separately CH3 groups. I'll take I'll break this bond carbon and put this CH3 to this one like this. Instead of putting this linear, the three carbon atoms, instead of putting linear, I will arrange like this. Then it's not linear, not in a straight line. Then also you get optical active. Now this is also optical active. Did anyone get this before I explain? Did anyone get this before I explain? Please raise the hand. Those who have got this structure before I explain. Is all this CH2, CH3, right? You can add hydrogen to make 4 bonds around each carbon atom. So these are the two structures, that is both are optically active, but they are not enantiomers of each other. Enantiomers means mirror images. They are not mirror images of each other, but they are two different optical active isomers for the structure compound A. Compound A, both this is C7H16, both has the same formula, but they are both are optical active compound. Okay. Now here also there are 4 different groups. CH3, here this one, and here this one. Any questions? Any questions? Then let's move on to the next one. The two state two isomeric relationship between the two structures we have drawn. What are these two isomers? What is the name given to these two isomers? They are both are optical, but how do they differ based on the change of what? Due to the changing of the carbon chain, no? Or the arrangement. Not due to the geometry, not due to cis trans, not due to optical. They are both optical, but how do they differ? By changing what we got this as two different isomers? By changing the structure. So they are called what? Part 2 the answer will be, part 1 this is the answer, part 2 the answer will be they are structural isomers. They are structural isomers, but they are given in the marking scheme. If you have given chain isomers also accepted for this. Chain isomers also accepted for this. They are optical structural isomers or chain isomers. Understood? chain isomers or structural isomers. Or chain isomers. Right. Is that clear? By changing the position, by changing the structure of the carbon chain, by changing the structure of the carbon chain. So can you remember, look at the summary of the isomer summary. I gave a flow diagram. Isomerism divided into two groups. Constitutional isomers, then the structural isomers, then the other side I put the stereoisomers, then enantiomers and geometric isomers. Okay, then next part, next one, B and C are optically active compound, optically inactive. B and C optically inactive. C7H14, both B and C exhibit geometric isomerism. B and C are not geometric isomers of each other. Catalytic hydrogenation will give the same compound AR. Shall I erase this? Did you all finish copying? Anyone still copying down? Okay, I'll erase this. So then they ask B and C, next part. Look at next part. B and C are optically inactive. Okay, again you have to pay attention to the keywords in the question. B and C optically inactive, and they have the same formula C7H14. And the next point they have given, both B and C exhibits what isomerism? Geometric. Both B and C are geometric. It can be cis trans or only geometric. They are not geometric isomers of each other. That means what? You can take B is cis and C is trans. That means not as cis trans. What is not geometric isomers is each other means what? You can't take B as cis and C as trans. So that means not as cis and trans. I mean, that's what it means. Not isomers of each other, not geometric isomers of each other. Then catalytic hydrogenation, the last one. Catalytic hydrogenation of B, either B or C. Catalytic hydrogen means addition of H2. Addition of H2. So these are the three key. Catalytic hydrogenation give the same compound A. Same compound A. From both B and C you get what? Same compound A. So I used three different colors for three different explanation given the data given in the question. Now let's see. Who can annotate on my screen? Can you predict the structure of at least B and C? C7H14, how to draw? Two optically active isomers. What is the formula given? C7H14. Is this an alkene, alkyno? First you have to check that. C7H14 means what? CnH2n. CnH2n. So this is what? Alkene, no? Alkene. That means there must be a double bond. There must be a double bond, no? There must be a double bond. So how to get B and C from this? What are the other conditions? B and C geometric there. Geometric there. That means there must be a double bond. Each carbon atom of the double bond, there must be two different groups attached. That is geometric is there. Plus one condition, that formula, one condition, second condition geometric. Yeah, that's what they have given. And both B and C give the same compound again, A. Yes, how to do this? Now don't worry about this. Now to get this, having that in your head, both, okay, look at this. You have to be very tricky. Since both B and C give the same compound A after adding hydrogen, both B and C give the same compound A. Then you can guess the skeleton of, okay, you can see the carbon skeleton of both B and C because of this information. Because both gives A after adding hydrogen. After adding hydrogen, both gives A. Compound A we have already predicted, no? Compound A we have already predicted. Add in hydrogen. So here also add in hydrogen. How to do this? I'll draw the structure of A again, then you can get a clue. Structure A is optically active. Without telling the B and C are optically active or anything, they have not given. So if you draw the structure A, then you can just to put the double bond. Carbon skeleton won't change. Just to shift the double bond between two carbon atoms. So this side you get CH2, CH3. And here you get CH2, CH2, CH3. Okay. Now how to place the double bond in B and C to make it geometric. From at the beginning we discussed the question. If I put the double bond here, I'll write here. If I put the double bond here, I'll put a pink one. Then I get geometric, no? That is one possibility. I'll get the geometric. If I put the double bond here. And the other place I can put the double bond here. Here. Did you get it? If I put double bond here, I'll get one structure. If I put double bond here, that is the only place I can put. Those are the two places. Those are the only two places which I can make double bond. Yeah. Okay. Accordingly, I'll draw this structure now. I'll put number 1. Then you get. I will draw this structure also. You get a double bond. Look at number 1 here. At the first position. Here I'll draw the double bond. Then this side you get what? CH double bond here. Then hydrogen is going out. This hydrogen is going out. Then this becomes CH3. This side you get CH3 group. And the other side you get CH2, CH3. And this side you get hydrogen, and this side you get CH2, CH3. CH2, CH3. Okay. If you want to highlight, here you get CH3. That CH3 is here. Then you get this side you get CH2, CH3. That is here. Then you get here CH2, CH3, that is here. And then you remove 2 hydrogen. To convert this to a double bond, you have to remove 2 hydrogen. What are the 2 hydrogens removed now? 1 hydrogen I'll highlight here. This hydrogen remove. Right? Then anyway 2 hydrogens should be removed because this is C7H16. C7H. What is that? C7H. A has C7H16, right? Alkane. C7H16 has become C7H14. Then definitely 2 hydrogen you have to take out. So I will highlight the 2 hydrogen that is taken out. I'll encircle that. This is 1 hydrogen. This is 1 hydrogen. I'll encircle. This is 1 hydrogen I have to remove, and this is the other. So here I'll remove 1 hydrogen. Yeah, I'll remove 1 hydrogen. Or else I'll put an arrow toward that. This is 1 hydrogen I should remove, and this is the other hydrogen. So these are the 2 hydrogen I have to take out to make it a double bond. Okay, is that clear, everyone? Then next one, I'll shift the double bond to the number 2 place, second place. Then you get this one, structure C. How? double bond here. I'll first draw the double bond. That means this position become the double bond here. In number 1 position, I take the double bond. In number 2 position, double bond. See the way I started from the product. From where did I start? From A itself, because they are telling both B and C gives both B and give both B and both B and C gives both B and C give A. So I did the structure A again, and then from that I predicted B and C by making what? To satisfy this geometric, that means there must be two different groups attached to each carbon of the double bond. So then only the two places I can place the double bond is what? Number 1 and 2. Number 1 and 2. Yeah, because the green one and the blue one highlighted, I can't make a double bond. It's not possible. It's not possible. Then you will not get geometry. You can put the double bond, you will not get geometry. You can put the double bond to the other places, but you will not get geometric structures. Two different groups attached to each carbon. So then again, what are the, so this side I'll draw, this side you will get CH2 number 2, second position double bond, then you get this side hydrogen, this side CH3. Then this side you get CH, and this whole thing come as one group. This whole thing become one group. H, CH3, here you get CH2, CH3. This whole thing become one group. Is that clear? This is the other structure. Okay. Any questions? So I tried it alone and have send it through WhatsApp. I predicted A by drawing B and C. Okay, very good, Ishara. Right, okay. But I told you, like, if you can use but it is called drawing pad or writing pad, like you can get for very low price now. It's available, must be available. Then you can connect to your USB in your laptop, and then or else even to your mobile phone you can connect, and you can annotate on my screen. Then I know what the mistakes that you are doing, then I can easy for me to explain, and we can reduce the time taken to explain, because I explain everything from zero now. Assume that you don't know this because no one replied the answer. Okay, is that clear? Do I need to explain? Did everyone understand this? So this B also geometric, C also geometric, but you can't take only C and divide that into cis and trans and cannot give B and C. That's why they have given, see the condition, they are not geometric isomers of each other. B and C are not geometric. That means B and C are not cis trans structures. So C you can draw cis and trans separately. C you can draw, okay, if you can add one more point here. C can draw cis and trans, but you cannot take those two as C and D the answer. Can draw cis and trans. Can draw cis and trans. But this one you cannot draw. This also can draw CH2, CH3, CH2. Yeah, this also can draw cis and trans, because this side equal and this side equal. Yeah, this side equal. Okay, understood? Here below the plane the groups are equal. Here above the plane groups are equal. That's why you can, this also you can draw cis and trans. If you draw cis, and sometimes they will ask in upcoming papers like that. If you draw cis and trans for both each A, B and C, how many structures you can draw for this? Can you reply? With cis trans, how many structures would you get from B and C? How many isomers? If you consider cis trans also for each B and C? Yes, can you reply? You can draw separately cis trans for B and you can draw separately cis trans for C, then how many structures would you get? Yes? No one is replying. Done. 4 structures, no? You can get? No. You can draw cis B, you can draw cis and trans separately, ne? Cis, now it's already cis and trans separately. So the given one is already cis, ne? You can draw one more structure trans. Right? Yeah, one, yeah. Already the given structure is cis, ne? Then all to the finally how many structures will be left all together? Already given one is cis. So this is cis, ne? So you can draw the trans for this. Then this side you have 2 structures, ne? This one, the given one is cis, ne? For this also you can draw the trans, ne? Then all to the how many structures will be left? That's what I'm asking. All to the how many structures you get? 4 structures, no? 4 structures. Good. Okay. Right. Then next part. Now they are asking, write the IUPAC names of B and C. Now that one you have to give me. Yeah. Give me, write the IUPAC name of B and C. Can you please write the answer now? IUPAC name of B and C. You have done the IUPAC with me. The next part in your paper. Next part. Can you quickly post the answer to the chat? IUPAC name of B separately, C separately. Yes? Not hard. Can you try? Okay, what is the answer? I got only from Pramudi. What is, okay, forget about this this structure. Now I think when you display like this, you will find it difficult to write the IUPAC name. I'll draw like this. I'll draw like this. CH3 C double bond CH CH2 CH3. Right? So here you have again CH2 CH3. Now can you write the IUPAC name of this? Now write. That is easy to number. Now is easy to number. The same thing I put. I didn't change it. The same arrangement without displaying like this geometrically. Then Now can you write the IUPAC name of B? Others also. Select the longest chain. How many carbon in the longest chain? Number in the longest chain. From which side I should start numbering? From which side I should start numbering? 1, 2, 3, 4, 5, 6. Is that correct? Or shall I? Okay, that is the longest chain, right? First tell me the answer for B. First tell me the answer for B. Then I'll ask for C. Right. What is this? 3-methyl 3-methyl 3-hexene or 2-hexene? 3-methyl 3-hexene, no? 3-methyl 3-hexene. Now in the exam, when you draw in B and C, it can be interchanged. Okay, if you want, you can put C as B and B as C. Like, I mean, when you draw the geometric forms. But after adding, you can't change it. 3-methyl 3-hexene or hex 3N 3-hexene, or else you can write hex 3-methyl hex 3E. I think that is better, no? 3-methyl hex 3E. 3-methyl hex 3E. But marking scheme, they have accepted this also. 3-methyl 3-hexene also accepted. But new syllabus, I prefer this one, the first one. Now how to draw this structure, this one, IUPAC name of this, I will start numbering like this. What is the condition? Double bond should get the lowest number. When number in C, double bond should get the lowest number. Double bond should get the lowest number. Please write it, everyone. When number in the priority, not for the substitute group, double bond should get the lowest number when number 1, 2, 3, 4, 5, 6. That is how you should number the chain. Okay. Now how to write the IUPAC name? How to write the IUPAC name? Now you can write it. So this is, I will highlight the substitute group here. This is CH3. CH3 acts as a substitute group, no? Wait. This is 1, 2, 3. Till. Four-methyl hex-2-ene. 4-methyl hex-2-ene. Yeah, 4-methyl hex-2-ene, no? Yeah, 4-methyl hex-2-ene. 4-methyl hex-2-ene. So in the paper, when you learn this IUPAC, you will learn separately, and isomerism separately, but in the exam is a soup. Okay. Is that clear? Who has given the ishara correct? Pramodhi 3-methyl hex-3-ene correct. Vinhara 4-methyl hex-2-ene. 2-ene ENE. Okay, this was very careful. Be careful. When if ENE come last, you have to put all 3 letters. If you want, you can mark that with a red pen. If EN come in the middle of the name, only EN. If EN come last, EN, all 3, this is in the middle. In the middle, EN comes as a side row, whatever, 2 in 1 in, then EN only. Please write it, because otherwise you will do the same mistake in the Excel. Sorry, this, right? Is that clear? Again, what did I tell? If EN come in the middle, only 2 letters. If EN come at the terminal, EN, it is in the middle, it's applicable for IN also. EN and IN terminal. When it is terminal, all 3 letters. Terminal one has all 3 letters. That is a short method, remember. Terminal, you have to put all 3 letters. So here in the middle, only 2 letters. Only EN. Okay, this is very important. Because I saw one of your answer, I think Vinhara, you have ended up with EN only, not ENE. Tamasha, we have put 1-methyl 1,5-dimethyl pentene. I don't know. I think you were not there when I was doing. I don't know whether you watched the recording, the isomerism and IUPAC part, because you missed at the beginning when I was doing Tuesday night. You missed some classes. No, you didn't join. I think your one is little bit problem. Others. Pramodi given 4-ethyl pent. Oh, pent? No, there are 6 carbon X. Okay, did you understand your mistakes now? Okay. You learn. Is that clear? Do you want me to explain it again? Please tell me. Okay, shall I erase this then? That is the end of this question. Done? Okay, I'll erase. Okay, then let's move on to the next one. Next one. Question number 4, 2014. A, B, C again. A, B are structural isomers of methyl pentane with formula C6. A exhibits geometric isomerism. B exhibits optical isomerism. On hydrogenation, A and B yield the same compound C with the molecular formula. C does not. Okay, this is very easy. This is easier than previous one. So can you give me the answer, or else you can annotate on my screen if you like. If you like, you can annotate on my screen. Yes. Any volunteers? Any volunteers? 14th part. (2014) paper. Yes. I'll give a clue. You do at home the rest. Okay. Because now you are a little bit okay and comfortable with this. Right, let's see. C6H12 structural isomers. Any volunteers here? Any volunteers to give the answer? Any volunteers? Oh, you can annotate on my screen. Have I given the permission to annotate on my screen? Yeah, you can annotate on my screen. Can you draw the structure of A and B? At least A and B. Any volunteers? What are the two conditions? Methyl pentane. Formula given. What is this? Alkene, right? C6H12 means first you have to decide from the formula whether it's an alkene or alkyne or alkane. Alkene. Plus they have given, it shows what isomerism? Geometric. Alkene with geometric isomerism, two different structures. And one of that exhibit optical also. B has optical also. Okay, I'll write here C6H12. C6H12, you have two structures B and C. B will be what? Geometric plus optical both. Geometric and optical both. Then C, only geometric. They have not given whether is this B optical, C geometry. Yeah, that's what they got. B optical, this is geometry. That's what they have given here. They have not given whether both B will be both geometric and optical. They have not mentioned. No, B exhibit optical, A will be geometric. So this is an alkene. Okay, can you guess the structure now? At least can you draw in front of B the possible structure for C6H12 with a double bond? For at least one of that you can choose, either C or B. This is A and B. No, sorry, not A and not B and C. A and B. Sorry about that. It's A and B. A and B. So after that, both A and B give the same compound C. C7H14, C6H14, C6H12 becomes C6H14. Okay, from this right. Okay, very good. You are drawing the optical one, no? Okay. Okay, right. Very good. Okay, so this is correct. This is correct. Very good. So this is optical, no? Very good. So then I will fill the hydrogen also to complete this. This is correct. Right. So this is CH2. This is CH3. And at the end you get the correct formula also. This is CH3. And this side you will have again CH3. There will be 5 bonds here, no? This side you cannot have CH2, CH2, CH2. So don't need to put hydrogen here. This side you can put hydrogen. Oh no, you have put the other side hydrogen, no? Wait. This side you don't need to put hydrogen. This side you can put hydrogen. Yeah. And this side you can put, okay, right, correct. This is one structure. If you want to further clarify, so when you put hydrogen here, what you get the same compound? Then you get here CH3, CH, CH3. No? We put here CH2. And here you get CH2, CH3. It is, I think, C, that's what they're asking. So geometric one, can anyone, this will be geometric. But this is not optical, this is geometric. This should be the B, right? Yeah, the one that you did, Pramod, it should be D. That should be B, I think. Where this is B in a geometric one. B is optical. Yeah, sorry. Yeah, B is optical. B exhibit optical. I have mixed up. A is geometric. I'll change this. A geometric. So it matched with the one that she has done. So this one, now anyone to do B optical, look at the screen, look at the question again. B optical, B exhibits optical. Now I want you to draw the B here. Any volunteers? B optical, optical B. Same formula, C6H12. There must be a double bond also. And it should be optical also. You make the optical and then put the double bond later. You decide the central carbon and then around the central carbon, make it optical. Okay, I'll put the central carbon. Any volunteers to draw around this to make it optical and with a double bond? Then it will not show double bond is there, but it will not show any cis trans, because yes, any volunteers to do this? How to attach 4 different groups here? How many more carbon left? 5 more carbon left. 5 more carbon left. Right. So this side I will put hydrogen. This side I put 2 carbon. This side I put 2 carbon. This side I put 1 carbon. Now check whether there are 6 carbon. So this side, how to make it? Now you might ask, so both these sides same. How can you make optical? But we can put a double bond. We can put this side double bond. Then it will be optical. Then it will be optical. Why? This side, even though there are 2 carbon, that side no double bond. So this side I can just put CH3, CH2. even though both side 2 carbon, left and the right side 2 carbon, but they will not be equal because of the double bond. So this side it becomes CH2, this side it becomes CH, right? Here CH3. Now see whether it's C6H12 now, right? First you have to put the skeleton and then attach the predict the double bond and then finally add hydrogen. Again I'm repeating. First what did I do? I wanted to make it optical. Then I put the central carbon atom and attach the remaining carbon. Having that in my head, but when there's a double bond between the carbon atom, it will be a different group, right? So from this, so with the hydrogenation, you get the same structure C, right? You get the same structure C. So if you add hydrogen, you get the same structure C from both these. If you want, you can check. It will not make any difference. Okay, so yeah, I mean, it's like this, it's CH2. You can rotate the molecule any direction you want. This is this one. So I'll put that is this one, this side. Or if I want, this is the, I'll put a different color. That is this group and this is this group. In CH3 I'll display like this. This is CH3 and that is CH3 here. Here it matched CH3. And this side pink one, pink, I'll put pink. This also I'll put pink. And the remaining one green. Match now? Like this, here CH2, CH3, CH2, CH3. Is that clear? You can rotate the molecule any direction you want, clockwise or anti-clockwise, and by rotating the molecule you can't take it's a different structure. By rotating the molecule you can't take it's a different structure. Is that clear? Please reply whether you have understood it or not. From both B and C you get the same structure C. From both B and C you get the same structure C. This is C, right? C. Clear? What about the others? Okay, which are understood? So Tamasha, yes, understood, right? What about Pramodi and Vinhara? Did you get it? Okay. Any questions? Done, right? Okay, good. Okay, very good. Now you can do all like 30 years papers you can do with gradually, like not at once. Now I had to do a little bit of the organic chemistry. We are at the beginning now. Alkene, aliphatic colony as the last question. Can you manage at home? That is this one. Now that last one can you do at home with this knowledge without looking at the marking scheme answers. If don't ever look at the marking scheme answers. If you look at the marking scheme, then your thinking ability is finished, right? And you directly, so alcoholic means what? Why alcoholic KOH? To remove HBr. So this is a halogenated one. So this one has bromine. So this is what, if you replace bromine also with hydrogen, then you get what? C5H. See whether this is an alkene or alkyne. C5H. If you replace this bromine also with hydrogen, then it becomes C5H12. That means it is an alkane, no? It is an alkane. When you remove HB, alcoholic KOH is added to remove HBr. We did a similar question to remove in HCl, like alcoholic KOH earlier. HBr is removed. When HBr is removed, you get what? Alkene having what? These structures AB and C gives D and E respectively, D, E, F. And then D exhibit geometric isomerism. Similar one, same set of words they rotate. When reacted with HBr, again you first to remove HBr and again you react with HBr, right? Then you get again different structures, and then optical isomerism. See all these optical geometric formula, optical geometric, and they have given a simple reaction, alcoholic KOH, one reagent. So this one I'll leave for you. Let's see how many of you will get this, right? Okay. So then next time then I will I did isomerism question here. Earlier also I did the isomerism paper, this one, like these basic reactions from reactions, chemical reactions of alkene alkyne. Now I just started benzene also with you, right? Benzene also I just started the reactions, but I didn't do much questions from benzene related one. So next week I'll do a little bit of the summary of theory of benzene. Please raise the hand. Those who have done aliphatic, those who have done in the theory class, please raise the hand. Alkene, alkane, alkyne at least done. I will done in the theory class. Isomerism part and alkane, alkene, then it will be additional. Then it's good. In the theory class, Ishar and Vinhar not done it, no? Alkene, alkyne, alkane, isomerism and the reactions, not it. Okay, then how many of you? Okay, please raise the hand. Those who have done benzene also, benzene reactions, or just started at least benzene the structure at least, not it. Okay, no problem. Then it will be additional support for you to understand your theory also. I'll explain benzene. I have already done it. The structure I have done. Then benzene, the reactivity I have done. Then benzene isomerism I have done. No, the isomerism, that is what it is called, hybridization of carbon. Then I did ortho-para-directors and meta-directors. Monosubstituted benzene I have done, and monosubstituted benzene reactions I have to do, right? So on that one I'll do next week first, and then we'll do the last question also I'll discuss. And benzene related questions also I'll start next week. Right, okay, then we'll stop for today then. It's already 8:35, right? Okay, then have a good day and God bless you all and stay safe.
Thank you, sir.
Thank you, sir.
Thank you, sir.